This is part 2 of our study on adding and subtracting rational expressions with opposite denominators. So make sure you go back to part 1 in the previous lesson and review what we've talked about there, because in part 1 we kind of reviewed some information from previous courses that brought us into the different paths of doing these problems. All right, so make sure you go back and review that. All right, so let's look at number 1. So as a quick review, we're going to use number 1 to kind of synthesize, summarize what we've done here in part 1. So in number 1, so remember the directions will say add or subtract. And notice that in our problems, the denominators will be opposites. So it's going to be important we talk about that. So number 1, we have 8 divided by x minus 7 plus 4 divided by 7 minus x. All right, so as you recall from part 1, this is not a difficult problem to deal with. It's fairly easy because, first of all, it's an addition problem. Secondly, the numerator, the second rational expression, is a monomial factor. All right, so that's going to be easy to deal with. But remember, in order to add or subtract two rational expressions, the denominators must be the same. Your factors must be the same. In this case, it's not. So you have to recognize, though, that those are opposites of each other. And so remember, in the previous lesson, in part 1, we did talk about the idea of opposites, and then that being the same thing as the additive inverse. So notice that the opposite of x is a negative x, and the opposite of negative 7 is a positive 7. So those are opposite of each other. Those are additive inverses of each other. All right, so what that means now is this. If since those are opposite, that means, and we always chose the second rational expression to do what I'm about to do. So that means that from this second denominator, I can factor out a negative 1. And when I factor out a negative 1, what's going to be in parentheses will be identical to this. Okay, so watch. So I get 8 divided by x minus 7 plus 4 divided by negative 1. And remember, what's going to be here will be this. So I'm going to rewrite that. And it kind of makes sense because, look, if I factor out negative 1 from here, negative 1 times x is a negative x. Negative 1 times a negative 7 is a positive 7. Okay? Now, at that point, that's where we talked about the two different paths. So some of you may recognize, okay, well, I want to do it this way. I want to do it where I see that I'm adding a negative 1 factor, and so that I'm going to write this as a subtraction problem instead. Okay, you can. That's fine. I get 8 divided by x minus 7, subtract 4 divided by x minus 7. All right, you definitely can do that. And so now the rational expressions have the same denominators. I can write this as one rational expression. And then I have 8 minus 4, which is just 4. And so there's your answer. Okay? Now remember, though, the other path that we talked about in part 1 was this. I'm going to go ahead and rewrite this over. So I got 8 divided by x minus 7 plus 4 divided by negative 1 times x minus 7. So the other path was where we took that negative 1 factor that's in the denominator and I wrote it in the numerator. All right, so remember in our discussion in previous part 1, that's where we looked at these simple examples to kind of understand that was what was happening. Okay, so that means this then. That means, all right, so I can write this as 8 divided by x minus 7 plus a negative 1 times 4 divided by x minus 7. All right, that's definitely true. And so now if I want to, I can write this as one rational expression. Well, it's not if you want to, you have to. So it's not a matter of want, it's a matter of you do. And so I want you to notice this though. See that negative 1 times 4? That's negative 4. So I get in my mind, I get 8 plus a negative 4, which is a positive 4. So you get the same thing. So it doesn't matter which path you take. Know both though. Know both. So notice the amount of work was basically the same. It's just that when you get to this point, some of you may still have a little bit of issue with signed numbers. See, most of you can see that 8 subtract 4 is 4. Some of you may have a little bit more difficulty with seeing that 8 plus a negative 4 is 4. So just it depends on your prior knowledge, how much prerequisite skills you remember. Okay, number 2. we have this. So let's look at another easy one. So we have 6x plus 8 divided by x minus 3 plus 2x divided by 3 minus x. So just remember what we talked about in part 1. When we talked about in part 1, whenever the second rational expression, that numerator, is a monomial factor, things are a lot easier to deal with. All right. So it does not matter which path you take. It's basically the same amount of work, no matter what path you take. If these are monomial factors, I'm sorry, this right here, if that second rational expression is a monomial factor in the numerator, it doesn't matter what path you take. It will be the same amount of work. Okay, so notice that I'm adding these two rational expressions. The denominators are not the same. In order to add them, the denominators must be the same. But I did notice they're opposites of each other. They're additive inverses of each other. So that means I can factor out a -1 here, and then that factor that's going to be parentheses will be the same as this. All right, so then I'm going to get 6x plus 8 divided by x minus 3 plus 2x divided by -1 times x minus 3. Okay, so remember, -1 times this gives you this. So, and I always check, -1 times x and -x, -1 times -3 is a +3. All right, and then again, it doesn't matter what path you take. You can think of this as a subtraction problem, or you can rewrite the -1 factor in the numerator. It does not matter. Okay, does not matter at all. To save some time for this one, since the paths are basically the same number of steps, I'm gonna think of this as a subtraction problem. So this can become 6x plus 8 divided by x minus 3 subtract 2x divided by x minus 3. All right. So now I have a subtraction problem. Now remember, when you have a subtraction problem, this is binomial, then you have a little bit more work to do. But it's a subtraction problem that's a monomial though. So in other words, when I write this as one rational expression, since they have the same denominator, my numerator, I have 6x plus 8 subtract 2x, and then combine like terms. 6x minus 2x is 4x. I get 4x plus 8. So that goes here. All right, and then I want you to notice that you want to try and simplify this. Remember, that's the next step. So you're going to factor if you can, and I can factor out a 4 here. So let's do that. So I get 4 times x plus 2 divided by x minus 3, and there's nothing I can reduce. So that's your answer. And again, leave it in factored form. Leave it in factored form. All right, so that was number 2. All right, number 3. Let's look at number 3. Now, number 3 is where we're gonna talk about the scenario where one path may be easier to deal with than another. So look what we have in number 3. We have 2x minus 1 divided by 3x plus 2. Subtract a -3x plus 2 divided by -3x minus 2. Okay? All right, now, so I want to subtract those two rational expressions, and that one's a little bit more complicated than the other two. Obviously, first of all, you have a binomial here. It's not a monomial. So it'll make things a little bit more challenging, but we can deal with this. And we'll do it both paths just to kind of remind you how this works. So first of all, you are subtracting, so it may make things a little bit difficult as well. But notice that in order to subtract two rational expressions, I need these denominators to be the same. They're not the same, but I do notice that they're opposites of each other. The opposite of 3x is a -3x. The opposite of +2 is a -2. So that means, and we always, remember, our approach is to always factor out a -1 from that second denominator. So I'm going to go ahead and factor out a -1 from that second denominator. My numerator is -3x plus 2. My denominator will be -1 times this. Okay, so 3x plus 2. Because -1 times this will give me this, -3x minus 2. All right. Now, for this one, it may be the easier path. I want you to think about what the easier path is. What the easier path would be to think of this. You're subtracting a negative, so think of this as an addition problem, or to take the factor of -1, put in the numerator. Yeah, the easier way would think of this as an addition problem. Whenever you subtract a negative, remember you're adding the opposite, so it'll be a positive. So this becomes 2x minus 1 divided by 3x plus 2 plus, and then this part of the rational expression. So negative 3x plus 2 divided by 3x plus 2. All right, so that's that easier path in this case. And so now the rational expressions have the same denominator, so I can write this as one rational expression. And my numerator, you're adding, so it'll make things easier. So, and let's combine like terms, put in descending order. 2x plus a negative 3x is a negative x. A negative 1 plus 2 is a positive 1. All right? And I can't factor out, even to say, well, can you factor out a negative 1? Yeah, you can factor out a negative 1, but it's not going to help you because nothing will reduce, so that you're done there. So you see how easy it was to use this path to come up with our answer? All right, let's do the other path. So the other path would be this. So I'm going to go ahead and rewrite the same problem because that's where we talked about our paths. So I have 2x minus 1 divided by 3x plus 2, subtract negative 3x plus 2 divided by negative 1 times 3x plus 2. Okay, what I want you to notice is that, see this negative 1? The other approach is to instead of having a factor of negative 1 in the denominator, you have it in the numerator. So this becomes, so you rewrite everything else over. So this becomes 2x minus 1 divided by 3x plus 2, subtract, and then that's negative 1 times, now remember you got to put that in parentheses, negative 3x plus 2 divided by 3x plus 2. All right, so you have that negative 1 factor. So this negative 1 factor was in the denominator, we put in the numerator. And then you would distribute, just like this. Okay, so then you have 2x minus 1. And by the way, you can also, you see this right here, subtract a negative 1 factor. That negative 1 factor is in the denominator, and we changed it to an addition problem. You could have done the same thing here. See that, subtract a negative 1 factor, and then you could go to this now. But many students will just want to go ahead and distribute, and that's fine. So you have 2x minus 1 divided by 3x plus 2, subtract, and then when I distribute, negative 1 times a negative 3x is 3x, and negative 1 times a positive 2 is a negative 2, divided by 3x plus 2. Now that's the one where you have to be careful. See, you're subtracting a binomial. Okay, so notice I have two rational expressions. They now have the same denominator, right? So I'm going to write this as one rational expression with that denominator, 3x plus 2. And then I'm going to go off to the side, since I'm subtracting a binomial. I'm going to go off to the side and do the work. So that's 2x minus 1, subtract in parentheses 3x plus 2. I'm sorry, 3x minus 2. And then you distribute. So I get 2x minus 1. And then the opposite of 3x is negative 3x. The opposite of a negative 2 is a positive 2. And then combine like terms. When I combine like terms, I get 2x and a negative 3x and negative x. A negative 1 and a positive 2 is a positive 1. And that goes here. So again, you get the same answer as this one. You cannot factor this, and there are no factors that I can reduce. All right, so notice the different paths we took. All right, so knowing both ways does help. Okay, number 4. So let's suppose we had this in number 4. We had 4x squared divided by 2x minus 3 plus 9 divided by 3 minus 2x. So 4x squared divided by 2x minus 3 plus 9 divided by 3 minus 2x. So notice that you're adding two rational expressions. So you're adding two rational expressions. The denominators are not the same. Remember, when adding or subtracting, you got to get the denominators to be the same. They're not. But they're opposites. So I'm going to factor out a negative 1 from here. Always the first step. Subtract, and I didn't mean subtract. Factor out the negative 1 from here. So I get 4x squared divided by 2x minus 3 plus 9 divided by negative 1 times, I'm factoring out negative 1. So whenever you factor out negative 1, this becomes negative 1 times this is this. So 2x minus 3, since they're opposites. All right. Now, I'm going to just go ahead and do one path since I'm adding a monomial, so that's just easy to deal with. I'm just going to go ahead and rewrite the factor negative 1 in the numerator. So I'm going to get 4x squared divided by 2x minus 3. Now, you could have done the other path. You could have written this as a subtraction problem instead. It does not matter, okay? And if you understand that. Plus, now, negative 1 times 9, right? Divided by 2x minus 3. So I actually wrote out that I'm rewriting that negative 1 as a factor in the numerator. You see it here. But I want you to also recognize that negative 1 times 9 is a negative 9. So that becomes 4x squared. Oh, by the way, I can now write this as one rational expression. So I'm going to do that here. And then the numerator becomes 4x squared plus the negative 9, which is 4x squared minus 9. So that's the numerator. Now let's factor. So that's the difference of two squares. So I get 2x minus 3 times 2x plus 3 divided by 2x minus 3, and then the next step is to reduce. So when I reduce, these factors divide out, and you just get 2x plus 3. All right? Okay, that was number 4. All right, let's look at number 5. Number 5, we have, let's say we had 5y minus 7 divided by 25y squared minus 4 plus 5y minus 7 divided by 4 minus 25y squared. All right, so that's what I have. So let's look at this. So notice I'm adding two rational expressions. The denominators are not the same, but I do notice that the denominators are opposites of each other. So I'm going to go ahead and factor out a negative 1 from here. So the opposite of 25y squared is a negative 25y squared. The opposite of negative 4 is a positive 4. So I get 5y minus 7 divided by 25y squared minus 4 plus 5y minus 7 divided by negative 1. So I'm factoring out a negative 1 from here. So when I do that, what I'm going to end up here with is this, negative 1 times this, 25y squared minus 4. Because remember, always think about why that's true. So 4 minus 25y squared. So when I factor out a negative 1 times a negative 4 is positive 4, right? And then negative 1 times a positive 25y squared is a negative 25y squared. And remember, addition is commutative. So the order in which I write it does not matter. So I'm going to put the 25y squared first, minus 4. And notice that is this. So that's why we always go, when we factor out negative 1, we just remember that this will be a negative 1 times that. Okay, so now you can do one of two paths. So for this one, see how you have a binomial here? So it might be easier, and it may not. So it may be where it's easier for you to rewrite this negative 1 factor in the numerator, but we'll do both. So at this point, so here's one of the paths. So I can think of this as adding a negative factor, so it becomes a subtraction problem. So that becomes 5y minus 7 divided by 25y squared minus 4. Subtract 5y minus 7 divided by 25y squared minus 4. Okay, so that's knowing that this right here is this. Okay, and then I want you to notice this. Now this one's easier to deal with. So now my rational expressions have the same denominator, so I can write this as one rational expression. But notice the numerator. So remember, you need a for some of you may need to go out and write out what this is. So this is, I'm going to put it right here. So this is 5y minus 7, subtract, and put this in parentheses, subtract 5y minus 7. Well, notice these two are the same expression. So 5y minus 7 subtract itself is what? Is 0. And if you didn't see it, go ahead and distribute. Notice what you get. You get 5y minus 7 minus 5y, and then the opposite of a negative 7 is a positive 7. And notice 5y, negative 5y is 0. Negative 7 plus 7 is 0. So basically, you get 0 in the numerator. And so 0, and I do know you can factor this, but 0 divided by whatever this is what? 0. So your answer is 0. That's your answer, 0. So that's the first path. Now the other path is this. So let me go ahead and rewrite this over right here. And I may need to use that next page. So I'm going to go ahead and use the next page. So the other way to do number 5 is this way. So I'm going to go ahead and rewrite. Let me just go ahead and do 5 stars. So this will be the other path. All right, so I'm going to rewrite the problem. So we had 5y minus 7 divided by 25y squared minus 4 plus 5y minus 7 divided by 4 minus 25y squared. And so remember, what we did was we factored out a negative 1 from here. So we get 5y minus 7 divided by 25y squared minus 4 plus 5y minus 7 divided by negative 1 times 25y squared minus 4. Okay, so the other path is where you take this negative 1 factor and you write it as a negative 1 factor in the numerator. So in other words, I get 5y minus 7 divided by 25y squared minus 4 plus a negative 1. Now remember, you got to put that in parentheses because it's a binomial. 5y minus 7 divided by 25y squared minus 4. All right. And then notice now I have two rational expressions with that same denominator. So I can write as one rational expression, and then let's go ahead and distribute. So let me go ahead and distribute first. So I'm going to rewrite these two over. So 5y minus 7 divided by 25y squared minus 4 plus, and again, the denominator is 25y squared minus 4. So when I distribute, that becomes negative 5y, and negative 1 times a negative 7 is a positive 7. All right. Now let's write this as one rational expression. 25y squared minus 4. All right, now here I'm adding, so it's easier to deal with than when I was subtracting. So since I'm adding now, so this is going to be 5y plus a negative 5y is 0, right? A negative 7 plus a positive 7 is 0, so that's 0, so your answer is 0. All right, so that's number 5. Okay, let's look at number 6. Number 6, we have this problem. So let's say we had 7 divided by p, 7 divided by p squared minus 7 plus p squared divided by 7 minus p squared. Okay? All right, so notice I'm adding two rational expressions. The denominators are not the same, but the denominators are opposites. So that means I can factor out a negative 1 from here. So I'm going to get 7 divided by p squared minus 7 plus p squared divided by negative 1 times p squared minus 7. All right, so remember, whenever you factor out negative 1 from here, then this becomes negative 1 times this. And that gives you this back. So always double check. All right, now, what I'm going to do is I'm going to just do one path here. So I'm going to rewrite this negative 1 factor in the numerator. So I'm going to get 7 divided by p squared minus 7, okay, plus a negative 1 times p squared divided by p squared minus 7. So all I did was I rewrote the negative 1 factor in the numerator. But that's a negative p squared, right? So it becomes 7 divided by p squared minus 7 plus a negative p squared divided by p squared minus 7. All right, so now I have two rational expressions with the same denominator. So I'm going to write this as one rational expression. And then I'm going to add their numerators, and let's put it in descending order. So this becomes, actually you don't have to. We can just put it as 7. You understand that 7 plus a negative p squared means the same thing as 7 minus p squared. Okay. Now here's where you got to think about this. Okay. So you may say, well, those are opposites, right? Those are still opposites, aren't they? So if I look at this, see the opposite of 7 is negative 7. The opposite of p squared is negative p squared is a positive p squared. So I can factor out a negative 1 again from either one of those. So I can say, well, that's going to be negative 1 times negative 7 plus p squared. Always double check. Negative 1 times negative 7 is 7. Negative 1 times p squared is a negative p squared divided by p squared minus 7. And then I want you to notice, y'all do see that this and this are the same, right? So negative 7 plus p squared is the same thing as saying p squared minus 7. Make sure you understand that. And then that's the denominator, so those divide out, and you're left with an answer of negative 1. So that one was a little bit tricky or challenging because what we ended up with, so we had these being opposites, and what we ended up with also was that the numerator and the denominator were opposites. All right. Now, remember in previous lessons, I just want to remind you of this. Okay, so in previous lessons, So remember in previous lessons when we were simplifying rational expressions, and then some of our factors were opposites, what we did, so you notice those are opposites, right? So right away, remember what we did? We divided those out. This was a positive one, this was a negative one, and so we get -1. So you could have gone from here to here if you wanted to and not go through all this process, but that's basically what's happening. When you do this, you're looking at it in terms of this, okay? All right, number seven, we have 8x minus 5 divided by x minus 5 plus 3 minus 6x divided by 5 minus x. All right, so in that case, notice I'm adding two rational expressions. The denominators are not the same, but they're opposites. So I'm going to go ahead and factor out a -1 from the second one. Always do the second one so that way you can look at your different paths that you want to take. It doesn't matter though, you can factor out from here, but it's always easier to rationalize what to do if you factor it out from the second one. So I got 8x minus 5 divided by x minus 5 plus 3 minus 6x divided by -1. So when I factor out -1 from here, that becomes -1 times this, x minus 5. And notice when you distribute, you get this back. And then what I'm going to do, so the easier path would be to think of this when you're adding a negative factor as a subtraction problem. So it's kind of like this. Let me remind you. So when I had, let's say we have 7 minus a -1. Then it becomes 7 plus 1, right? And that's well, that's not this one. So if I had 7 plus a -1, do y'all agree it becomes 7 minus 1? All right, that means the same thing. So I'm going to rewrite this as subtraction. So adding a negative factor, adding a negative number becomes that. So it becomes 8x minus 5 divided by x minus 5 minus, and then that's 3 minus 6x divided by x minus 5. All right? And so now what I'm going to do is notice that these two rational expressions have the same denominator. So I'm going to write this as one rational expression. And then go off to the side and figure this out because you are subtracting a binomial. So let's figure out what that is. So I got 8x minus 5 minus 3, in parentheses, 3 minus 6x. Then distribute. So I get 8x minus 5 minus 3 plus 6x. And they combine like terms. 8x plus 6x is 14x. A -5 and a -3 is a -8. All right, so that goes here, 14x minus 8. All right, the next step is to reduce. To factor and then reduce. So if you notice, I can factor out a 2, but that's not going to help at all if you do that, because when I do that, notice that there are no common factors. So if you notice that, you can either leave your answer like this or like this. If you leave it like this, though, just leave it in factored form. But notice that these two are the same thing. You cannot reduce, so either one of those would be your answer. But notice, though, if you can factor and reduce, then you got to reduce. Okay, just don't factor. You got to reduce after that if you can. All right, so that was number 7. Let's look at number 8. So number 8, we have x squared plus 2xy divided by y squared minus x squared, and I'm subtracting y squared divided by x squared minus y squared. All right, so that's our problem. So I'm subtracting two rational expressions. The denominators are not the same. See, this is y squared minus x squared. This is x squared minus y squared. But they're opposites. The opposite of y squared is a negative y squared. The opposite of a negative x squared is a positive x squared. So that means I can factor out a -1 from here. That's always your first step if they're opposites. So let's go ahead and factor out a -1. So I'm going to rewrite this over. X squared plus 2xy divided by y squared minus x squared. Subtract. And then this becomes y squared divided by -1 times this. So y squared minus x squared. Okay? And then what I'm going to do, since I use this path here, I'm going to go ahead and, for this path that I'm about to do, I'm going to go ahead and rewrite the -1 factor in the numerator. But you could have said, subtract the -1, you could have changed that to an addition problem. You understand? All right, but I just want to do this particular path. Since we don't have a lot of time left with this lesson. So I have x squared plus 2xy divided by y squared minus x squared. Subtract, and then I'm going to rewrite the factor -1 in the numerator. So it'll be -1 times y squared divided by y squared minus x squared. Okay? All right, now, notice that -1 times y squared is a negative y squared, right? Okay, so that becomes y squared plus 2xy divided by y squared minus x squared. Subtract, and then this is minus y squared divided by y squared minus x squared. Okay, so -1 times y squared is a negative y squared. Now, since the two rational expressions now have the same denominator, we write this as one rational expression. And then this becomes this. Now, it's important you see this. Okay, so I'm going to go off to the side. I'm going to go off here and do that. So I'm going to write this numerator here. So I'm going to get y squared plus 2xy minus a negative y squared. But do you understand that subtracting a negative y squared, this becomes y squared plus 2xy plus y squared? Okay, so that's the numerator. Y squared plus 2xy plus y squared. Now remember, the next step is to factor. So I'm out of room here, so I'm going to go ahead and draw an arrow here. So when I factor the numerator, I get, notice the two variables. So this is a perfect square trinomial. So I'm going to get x plus y times x plus y. So that's the numerator. The denominator is the difference of two squares. So I get y minus x times y plus x. Okay? That's how you factor that. Now notice, let's see if we have any common factors. Do you see any common factors? There are no opposites here. I don't see any opposites. But I do see that x plus y is the same thing as what? Y plus x. So those divide out, and your answer will be x plus y divided by y minus x. Okay? All right. So we did number 8 using the path where we rewrote the -1 factor in the numerator. Now the other path would be to take this and change it to addition problem, and in that case it would be easier to deal with. All right, so watch. Let me show. Actually, let's do that path. So I'll show you what's going to happen. Okay, so the other path. So remember, the path that we took here was we rewrote the -1 factor in the numerator, and that's what this is. And so sometimes it can be easy. Sometimes it may be a little bit more challenging. The other path, though, and let me go ahead and rewrite this for the other path. So that's what we had here. The other path was to, once you factor out the -1, was to recognize that I can rewrite this, subtract a negative factor, as an addition problem. So this becomes x squared plus 2xy divided by y squared minus x squared plus this rational expression, y squared divided by y squared minus x squared. And then notice I'm adding two rational expressions. Now they have the same denominator, so I can write this as one rational expression, y squared minus x squared. And the numerator, see, this is an addition problem now. See right here, when I chose that other path, it became a little bit more difficult because you are now looking at a subtraction problem. So we had to be careful how we approach that. So notice the work we had to do. Here, though, it's not that bad because x squared plus 2xy plus y squared is just what you see. X squared plus 2xy plus y squared. There weren't any like terms. So I just rewrote the terms over and put it in descending order in terms of the variable x. So x squared, x to the first, and then no x. But now we got a factor. So once you get into that one rational expression, the next step is to factor because you want to simplify this if you can. So again, when I factor this, I get x plus y times x plus y. And that gives us this trinomial. So that's a perfect square trinomial. The denominator is the difference of two squares, so I get y minus x times y plus x. And then you reduce common factors. And so the only factors you can reduce are these two because those are identical. X plus y is the same thing as y plus x. You get ones in there as their factors. And so the answer is x plus y divided by y minus x. And that's what you had here. All right? So that's what we had here. So notice, though, the different paths, depending on the situation that you're dealing with, different paths can be easier than others. All right? Okay, and let's look at number 9. So in number 9, let's suppose we had this. We had x minus 8 divided by x squared minus 49, and I want to subtract x minus 8 divided by 49 minus x squared. All right, so let's see what we get there. So I'm subtracting two rational expressions. The denominators are opposites. They're not the same, but they are opposite. So let's go ahead and factor out a negative 1 from here. So when I do that, I get x minus 8 divided by x squared minus 49. Subtract x minus 8 divided by, and that's going to be negative 1 times this. So x squared minus 49. All right, and so then I'm going to go ahead and use the path. I'm going to use this path here with number 9 that we did here. So I'm subtracting a negative 1 factor, so I'm going to write this as an addition problem. So it becomes x minus 8 divided by x squared minus 49 plus x minus 8 divided by x squared minus 49. Okay, and so now I'm going to add those two rational expressions so they have the same denominator. I'm going to write it as 1, just like that. And so I get x, 2x, x plus x is 2x, and then negative 8, and then negative 8 is a negative 16, right? And so if I factor, so we got to try and factor and see if we can reduce. So when I factor this, I'm going to get 2 times x minus 8, and then over here, that's going to be x minus 7 times x plus 7, and I cannot reduce. So I would just leave the answer like this. So leave the answer like this. Okay? So notice that this path here, taking this path, changing the addition problem, was easier to deal with. All right, let's look at another one. Let's see. Let's do this one. So this should be number 10. So number 10, we have x squared plus x minus 9 divided by x squared minus 3x minus 10, and I'm adding 3 plus 5x divided by 10 plus 3x minus x squared. So I want you to notice now, we have a trinomial. All the others we've done were binomials, but that's okay. Notice that these two are not the same denominator, but they're opposites. X squared, negative x squared. Negative 3x, positive 3x. Negative 10, positive 10. So I'm going to go ahead and factor out a negative 1 from this denominator. So I get x squared plus x minus 9 divided by x squared minus 3x minus 10 plus 3 plus 5x divided by negative 1 times. And so remember, when you factor out negative 1 from here, that's going to be negative 1 times this. So x squared minus 3x minus 10. And then I'm just going to go ahead and use the path where when we add a negative factor, then that's going to be a subtraction. So I get x squared plus x minus 9 divided by x squared minus 3x minus 10. And then I'm subtracting 3 plus 5x divided by x squared minus 3x minus 10. Okay? All right, now here's where you see you're subtracting a binomial, right? So you got to go off to the side and be careful with that. So I have x squared plus x minus 9, and then I'm subtracting this in parentheses, 3 plus 5x. So now I'm going to get rid of the parentheses, so this becomes x squared plus x minus 9 minus 3, and then the opposite of 5x is a negative 5x. Combine like terms, let's put this in descending order. I get x squared, x and a negative 5x is a negative 4x, a negative 9 and negative 3 is a negative 12. All right? So when I write this as one rational expression with that denominator, x squared minus 3x minus 10, the numerator is this. So x squared minus 4x minus 12. All right, so once you write as one rational expression, remember the next step is to simplify this. So let's go ahead and factor. So when I factor the numerator, I'm going to get x minus 6 times x plus 2. So that's the numerator. when I factor the denominator, I'm going to get x minus 5 times x plus 2. And then notice the next step is to reduce, and I can reduce, so those divide out, and so the answer is x minus 6 divided by x minus 5. Okay? All right, so that's number 10. Let's do one more. We have time for one more. So let's do one more. So this is going to be number 11. So let's see what we get in number 11. So in number 11, we have 3x divided by 9x squared minus 16 plus 4 divided by 16 minus 9x squared. All right, so notice I'm adding two rational expressions with unlike denominators. So the denominators are not the same, but they're opposites. So that means I can factor out a negative 1 from here, and then it's eventually going to look the same. So I get 3x divided by 9x squared minus 16 plus 4 divided by negative 1 times. So remember, you factor out negative 1 from this denominator, it becomes negative 1 times this. So 9x squared minus 16, and always check. Negative 1 times 9x squared is a negative 9x squared. Negative 1 times negative 16 is a positive 16. Now, I'm going to use in the previous problem, I used this path where I changed it to a subtraction problem. What I'm going to do now is go ahead and rewrite this negative factor that's in the denominator and put it in the numerator. Just to remind you about the different paths you can take. So 3x divided by 9x squared minus 16 plus a negative 1 times 4. See, I'm rewriting the negative 1 factor in the numerator, divided by 9x squared minus 16. And then now notice that these two rational expressions have the same denominator. So I can write this as one rational expression. And then the numerator is just 3x. Now remember, 3x plus the negative 4, that's a negative 4, is 3x minus 4. So that one's easy to deal with. Now the next step, once you write that one rational expression, you got to simplify now. So now you got to reduce, you got to factor. So I can factor the denominator, that's the difference of two squares. So in the numerator, I have 3x minus 4. The denominator becomes this. It becomes 3x minus 4 times 3x plus 4, and then reduce. So these divide out, make sure you put ones in their place, and you end up with 1 divided by 3x plus 4. Okay, so this was part 2 of our study on, let me get that first page. So this was part 2 of our study on adding and subtracting rational expressions with opposite denominators. So it's just a continuation of our discussion on what to do with opposite denominators. All right, so the different paths you can take, either this path or this path, where you take the negative 1 factor and put in the numerator. Okay, so that'll be the end of this lesson.